Welcome dear students. So today we'll start the third module in the subject Environmental Engineering 1. So this module mainly deals with water treatment processes. So these are the topics that we shall be discussing in module 3, treatment of water, theory and principles of sedimentation tanks, Stokes law, types of settling. Mainly we'll be dealing with type 1 and type 2 settling, coagulation, mixing and flocculation, design of sedimentation tanks. So here we will be discussing the design of circular as well as rectangular sedimentation tanks, and Clary flocculator. So in the early modules or in the earlier classes we discussed what are the various sources of water, then the intakes, conveyors, the characteristics of water, the physical, chemical, etc. So this time in this module we are going to discuss what are the various steps involved in the treatment of water. So the first process in any water supply scheme or in designing any water supply scheme is to locate or identify the source of water. So like we discussed, the source of water may be either surface water or it can be groundwater. So after having identified or located the source of water, then we have to transport the water using conduits or conveyors, as we already discussed, and this has to be transported to the treatment unit where the water shall be treated in order to remove the various impurities that are present in water. So after treatment we can say the water quality changes. It will not be the same as it is obtained from the source. It will become potable or it can be consumed by the public. We know that the raw water that is obtained from various sources contains impurities, and these impurities may be in the form of suspended particles or it may be in colloidal or dissolved state. So the main purpose of water treatment is to remove all these impurities, especially the ones which are objectionable from taste or the point of odor. Okay, and the main objectives of water treatment are firstly to remove the color, the dissolved gas and murkiness of water, and also to remove the objectionable taste and odor. So if water has an objectionable taste or if it has some odor, what happens if we cannot consume it? So in order to remove the taste and odor that is present in water, we have to undergo the water has to be treated. Also to remove the hardness of water. So if water is hard, what happens? It will not form lather with soap. So if water is hard, again it cannot be used for domestic purposes. So hardness has to be removed. Again, for this purpose we have to treat the water. And also in order to make water suitable for a wide variety of industrial purposes also, we have to treat the water. And only when it is treated we can say that water is safe for human consumption. And it has to be, water also has to be aesthetical, appealing aesthetically, so that the consumer can use it. And now coming to the various standards for drinking water. So there are certain standard values that are fixed for various parameters, like the physical parameters and the chemical parameters as well as the biological parameters. For example, we had discussed turbidity, color, taste and odor, etc. So if water has to be potable, if water needs to be consumed by public, then they have to conform to certain standards so that the value of the given parameter does not exceed the standard specified value. If it exceeds, what happens? It will not be fit for drinking. So these are as shown in the table. These are the desirable or the tolerable limits of various parameters. So like you see, turbidity, for example, turbidity, it's a physical characteristic of water. So desirable value is it should be less than 10. So suppose the value is slightly above 10, we can allow up to 25. Suppose the source cannot be changed, that is what you see in the third column. If there is no other alternative source and the turbidity exceeds the permissible limit 10, up to 25 it is allowed, or that will be the maximum limit up to which the turbidity of water can be allowed. And color, again we had discussed in the previous class. The desirable or tolerable limit is less than 10. And when it comes to taste and odor, it is unobjectionable. The taste, there should be no taste, there should be no odor. Only then we can say water is fit for drinking. Likewise, you can see for various other parameters also it has been listed here. The pH of value for drinking water, the pH desirable value is between 7 to 8.5, and allowable one is what is given in the third column as you see here. And even for hardness, the value is 200 to 300, that is in parts per million. So up to 600 it is okay, but still the desirable value is 200 to 300. So these are the other parameters, chemical parameters, and their desirable or tolerable values. So like this we can say that there are certain fixed standards for various parameters in when it comes to drinking water. Now coming to a typical conventional water treatment plant. So here we can say a typical water treatment plant has the following, these are the following processes that are usually done for a typical treatment of water. So firstly it is screening, then comes coagulation, then there is flocculation, sedimentation, filtration, disinfection, then storage and distribution. So I'll just give you a brief introduction on what are these processes. So coming to screening, so screening is mainly adopted to remove the floating matter from the surface water. Suppose we are collecting water from a lake or a river for public supply. We know that these surface water may contain some floating objects in it, like paper, dried leaves, or whatever it is. So the process of removing the floating matter that is present in water, we call it as screening. So usually this process is done, or it is generally provided at the intake point. So we know what is an intake. It is a point from which water is taken from the source to the treatment unit. So this process we call it as screening, that is removal of the floating matter by providing screens. Then there is another process, we call it as aeration. So aeration is a process which is mainly adopted to remove the unobjectionable taste and odor that is present in water, and also it removes the dissolved gases like carbon dioxide, hydrogen sulfide, etc. And slight amount of, to some extent we can say, iron and manganese that are present in water also may be removed by the process of aeration. And aeration is not a mandatory process, this is just an optional process, and it is not adopted in cases where water does not contain any objectionable taste or odor. So we can't say it's not a mandatory process, whereas screening is mandatory when it comes to surface water as a source. Then there is another process that is called sedimentation, and sedimentation again can be with or without coagulation. So the purpose of sedimentation is actually to remove the suspended impurities. So like I told you, there are water may contain suspended, colloidal or dissolved impurities. So sedimentation is the process where we remove the suspended impurities that are present in water, and this may be either plain sedimentation or sedimentation with coagulation. So plain sedimentation means the water will be allowed to settle by detaining it in a tank for a definite period. So what happens? The silt and the sand that are present in water will settle down. So thus we can remove this. So that is called plain sedimentation. Sometimes there may be very fine suspended particles or there may be some bacteria or some other organisms present. So these can be removed by a process we call it as coagulation. So coagulation is a process where you will be adding some coagulant to the water. Example, like you see here, alum. So alum or some coagulant will be added so that it will form flocks, and this coagulant will react with these fine suspended particles and it will form flocks which can be easily settled and removed. We can remove it. Then we have the process of filtration. So filtration is nothing but the process of where it is actually a very important stage in the treatment of water and the purification of water. One of the most important process is the filtration process. So this process actually removes very fine suspended impurities as well as the colloidal impurities that would have escaped the sedimentation tank. So already in the sedimentation process we will be removing the finely suspended particles. Sometimes there may be some particles that are left out without being removed in the sedimentation process. So such particles will be removed in the filtration process. And also in the filtration process, the microorganisms present in the water are also removed to a larger extent. Now coming to the disinfection process. So disinfection is a process which is carried out towards the end in any treatment process, and it is mainly to eliminate or to reduce to a safe minimum limit the microorganisms that are present in the water. So we know that if pathogens or disease causing microorganisms are present in water, it will be harmful for health of the person who is consuming such water. And disinfection is a process wherein we will be eliminating or removing such pathogens from the water, and it also helps in preventing the contamination of water during the transit from the treatment plant to the place of consumption. So once the water has been completely treated, we will be storing it in some tank or something, and then we will transfer the water from the storage point to the households. So during that transportation also there may be contamination. Suppose there is a leakage in the pipe which distributes water, there may be contamination from external sources. So for this purpose, even in the distribution system we will have to provide some disinfection method so that it eliminates or reduces the effect of the pathogens. So distribution is nothing but a network wherein water shall be collected from after treatment from the storage unit and distributed. It's a pipe network by which you will be transferring water from the storage tank to the various households. So this is a typical conventional water treatment plant layout. So we will be discussing each process in detail in the coming classes. Now coming to the functions of water treatment units. So like I told, there are various processes. So each process will have a specific function in the treatment process. Firstly, like I told you, aeration. So aeration is a process wherein the color, odor and taste of water shall be removed. And again, screening is a process where we remove the floating matter. So for floating debris that are present in water can be removed by the process of screening. And like chemical, there are also some methods, we call it as a chemical method of treatment. So in this we remove various metals like iron, manganese, etc. Then there is a method, we call it as softening process. So softening process means the process of removing the hardness that is present in water. So hardness is mainly due to the presence of carbonates and bicarbonates of chlorides and sulfates. Now sedimentation process, like I told you, it is a process to remove the suspended matter, and sedimentation, that is plain sedimentation. When it comes to sedimentation with coagulation, it also removes a part of the colloidal matter as well as some bacteria. Then coming to filtration, in filtration process any remaining colloidal dissolved matter also may be removed by the process of filtration, and it is one of the most important treatment process, or one of the most important process in the treatment of water. And finally disinfection, it is a process where you remove the pathogenic bacteria, any organic matter, or it is all any other substances that are present in water which are detrimental to the health of the person or people who are consuming the water. So these are the various functions of the treatment units. So this is a brief introduction on what are the various processes of water treatment. So we will be discussing each in detail in the coming classes. So now again coming to the selection of treatment process. So whenever like I told you, the treatment process, that we will decide the process of treatment based on the type of water that we use, that is used for public water supply scheme. So suppose the source is a groundwater source or a spring water, we know that it will be, there will be very less contamination in that. So in such when the source is a groundwater or a spring water, then literally we don't need a treatment at all. So based on the source, we have to decide, we will be deciding what type of treatment is required. Now suppose it is groundwater with slight chemicals or minerals or any gases that are present, then in order to remove the gases, we can use the process of aeration. Then there are chemicals which can be removed by coagulation, and also filtration and even disinfection can be done. Now suppose the source is lake or surface water reservoir which is not much polluted. Again, only disinfection may be sufficient. We need not go through all the processes, but only by disinfection maybe the water can be made potable. Now other surface sources like rivers or canals or any other impounding reservoirs which has considerable amount of pollution or which is highly contaminated, then we will have to have the complete treatment process. So all the process we have discussed earlier has to be done for water which is highly polluted. So again, so we can say that the selection of the treatment process mainly depends upon the source from which the water is being taken for supply. So I hope you've got a brief idea on what are the various water treatment process. So in the coming classes, we'll be discussing in detail each of these processes. Thank you.